Okay, so we are going to continue with solving systems of equations using matrices. Today we're going to talk about some special cases. Let's take a look at this first matrix, this first system of equations here. First, we're going to put it in our matrix. So you get 1, 2, 1, 8, 2, 3, negative 1, 13, 1, 1, negative 2, 5, and of course that's an augmented matrix, right? So what we're going to do is the following. I'm first going to eliminate this one, right? And the way I'm going to do that is I'm going to do row 1 minus row 3. So that's 0, 1, 3, 3. Next, okay, and today I'm actually going to combine steps in one. You can actually do that so you don't have to rewrite the matrix over and over again. The next thing, remember, we have to get rid of is this one, right? And I'm just going to do it in one step. The way to get rid of that one, I'm going to do 2r1 minus r2. Okay, so 2 times 1 minus 2 is 0. 2 times 2 is 4. Minus 3 is 1. 2 minus negative 1 is 3. 16 minus 13 is 3. And the top row, I'm just going to leave it the same. Okay. So take a look at what we have here. We end up with 2 identical rows, right? When you have 2 identical rows, that gives you infinitely many solutions. All right, that's the equivalent. Remember when we used to solve a system of 2 equations and you had 2 lines and the lines would be the same line, so like they would lie right on top of each other? This is the equivalent of planes lying on top of each other. Okay, 2 planes lying on top of each other. So there's an infinite number of rows. Okay, so we have an infinitely many solutions here. So now what we do is we're actually going to still write an expression for a solution, right? So what we're going to do is this. First, you need to take one of the bottom 2 equations and solve for y. So what do we get here? Let's take the red, right? And we get y plus 3z is equal to 3. So y is equal to 3 minus 3z. And you're going to have z in there. That's okay. All right. Then what you're going to do, step 2 is you're going to go to equation 1 and solve that one for x. So what does equation 1 tell us in that matrix? That x plus 2y plus z is equal to 8. So that's x plus 2 times, what did we say y was? 3 minus 3z plus z is equal to 8. Solving, I get x plus 6 minus 6z plus z is equal to 8. Finally, when I solve for x, I get that x is 2 plus 5z. So you see here too, my expression is in terms of z, and that's okay. And now, when I write my coordinate point, I have x is 2 plus 5z, y is 3 minus 3z, and z is just z. You just put z in there. This now gives you an expression for all the possible solutions of this matrix. So what you can do is one by one, you can generate all of the different solutions. So remember, when we get infinitely many solutions, it's not all real solutions. It's not all real numbers. You just have an infinite number of them. So by, if anybody wanted, they could plug in different values of z and generate the different coordinate points. Okay. All right, let's do another one. This one, when I convert to a matrix, to an augmented matrix, I get 2, 3, minus 1, 1, 1, 1, negative 2, 5, 1, 2, 1, 8. Okay, so what I'm going to do first is I'm going to get rid of this one. For that one, I'm going to do row 2 minus row 3. So I get 0, minus 1, minus 3, negative 3. Okay. Next, I want to get rid of this one. And to do that, I'm actually going to do row 1 minus 2 times row 2. And here I'll get 0. Row 1, 3 minus 2 times 1 is 1. Row 1 minus 2 times row 2 is 3. And then finally, that equals to negative 9. Leave the first row the same. Okay. Right, well, here's what we have now, right? Next, I want to get rid of this one. To get rid of that one, what I want to do is, I just want to do row 2 plus row 3. Okay, so let's do row 2 plus row 3. That'll get rid of that negative 1 there. So at the very bottom, I'm going to have 0. 1 plus negative 1 is 0. 3 plus negative 3 is 0. Negative 9 plus negative 3 is negative 12. Okay, and here we run into a different type of problem. I don't even need to continue, because what this is telling me is 0x plus 0y plus 0z, basically 0, is equal to negative 12. And when does 0 equal to negative 12? Never. So this is no solution, right? So that's the difference, is when you have zeros equal to a number, that's when you get no solution. But when you get two identical rows, that's what gives you an infinitely many solutions. All right, let's do one last one. Here I have 1, minus 1, 1, 3, negative 1, 2, negative 1, 2. And then I have 2, negative 3, 3, 8. Right. So first, I want to get rid of this 2, right? So let's get our matrix here. All right. To get rid of that, what I'm going to do is I'm going to do 2r2 plus r3. Okay, so that'll give me negative 2 plus 2 is 0. 2 row 2, that's 4, plus negative 3 is 1. Negative 2 plus 3 is another one. 4 plus 8 gives me 12. Okay. Next, I want to get rid of that one. And to do that, I'll just add row 1 plus row 2. So I get 0. So remember, only the row in which you're eliminating an element is the one you change. Okay. So you get 0, 1, 0, 5. I'm going to color code that to know that that's the one we changed. And the one that we are not going to change for the time being is this one. Okay. And let's see. Next up, I want to change this. And to do that, I'm just going to subtract row 2 minus, I'll do row 3 minus row 2. So that's 0, 0, 1, 12 minus 5 is 7. I could have done row 2 minus row 3, but I realized doing it this way will give me positives, so I just did it that way. So here these stay the same. And this actually gives us an even simpler situation, because from row 3, I get that z is equal to 7. From row 2, look, everything's 0 except for this y term. So I just get that y plus 0 is equal to 5. And then from row 1, I get that x minus y plus z is equal to 3. So x minus 5 plus 7 is equal to 3, meaning x is 1. So finally, the solution is at 1, 5, 7. Okay? And those are some special cases. Thank you. Have a good day.